Academy Foundation presents the second law. The first law defined an object and the effects of context on the object. The second law addresses how kinetic information is applied, explaining the inefficiency to acceleration and entropy coming into and going out of focus. At rest, energy appears contained within discrete identities like the player, ball, and field. Discrete energy stays with identities. The second law is focused on transferable heat energy and its effects. Thermal energy has translational linear effect. Entropy interferes with angular vibration. Let's see that again. The player conveys heat energy in the form of linear translation coming into focus with the kick. That simultaneously causes entropy to increase by making the ball move independently. The ball now has the heat that it acts on by translating out of focus away from the player, which is resisted by the entropy now converging back to equilibrium. Independent of the environment, entropy increased when the ball was put into motion. Stopping the motion decreases the entropy. We've all heard that entropy only increases. This is not how Clausius envisioned it. Entropy is a diversity of independent motion. It isn't about diversity of static parts. The mess of bricks can still be moved as one object. There's a good chance a brick will fall away, increasing entropy. The stacked bricks are easier to move without increasing the entropy. Applied locally, rotation is d, internalizing the entropy as angular dilation. It expands the scale so that other spaces try ripping themselves apart. The translation internalizes as linear thermal expansion, tangent to the surface. It begins at the volume parallel to the surface within the range of surface gravity. Heat is both temperature and entropy. Temperature affects motion, whereas entropy affects how the motion applies among a set of things. When we add heat to a solid, the identity of that solid resists the change in entropy. The solid state applies until thermal expansion exceeds the local range of surface gravity. At this point, the entropy of the group changes because the parts are moving semi-independently. The liquid state applies until the expansion exceeds the local displacement of mass. Now entropy finds independence and the effect accelerates as individual translation. Here we see water evaporating, but not necessarily as a proper gas because thermal expansion has affected specific weight and structural organization. The example still works to show entropy coming in and out of focus in a local heat cycle. The spaces R, X, Y, and Z are manifolds adapting to context. X is the conventional symbol used for the forward motion of simple translation. Y internally is dilation, while R is a surface acting on the volume Z. The distribution is the difference between the kinetic and discrete spaces. We need to be careful how we present and read these laws. There are nuances. Thermal energy converts into entropy, and entropy converts into thermal energy. Both also convert into spatial definitions. How depends largely on the context provided. Engineers understand this and adapt to it because they have to make things work. When all you're doing is looking at things and trying to interpret what you see, it is easy to get turned around a little bit. Clausius was practically explaining how energy of motion transforms into different roles. He was doing it long before some of these concepts like manifolds and dilation were worked out to show just how complex this is. So we can be understanding how Fritz Zwicky got a tad baffled applying Clausius's Virial Theorem. Zwicky was measuring kinetic mass. Kinetic mass adds to the discrete mass of the parts as part of a greater whole. Or as Aristotle said, the whole is greater than the sum of its parts. The whole issue of dark matter isn't actually about discrete matter. It is about motion. Of course, you can only see its effect on matter, and it doesn't account for the space and light between. Zwicky added up the momentum of all these moving bodies. If those bodies weren't drawn into a shape, the angular effects of entropy would interfere and shepherd them into a shape. Then things either get normal or very strange. Bubbles are a prime example of moving bodies forming a group identity using a boundary of surface tension. Whether it is this or the surface of a solid, it is a contextual effect of the Virial Theorem. The motion of the parts is creating what is called a hypersurface, which we are showing as the R manifold. Hypersurfaces are subject to hypersphere context. It starts with the zero sphere being just the value without a shape. The one sphere is the value as a surface, presumably a circle. The two sphere is a volume shape to which the surface is applied. The three sphere applies the surface to the volume, like filling a balloon or bubble. Finally, when the surface and the volume mix in lesser proportions than the whole, they are said to be gloaming. This is how Einstein envisioned surface gravity working. Spaces are constructed in particles until complete points of space are established. Starting with atoms, space-time is breaking down to distribute across time, separating things. Celestial objects are separated by vast volumes of time. The bubble-like effect shepherds the bodies into a common shape and a center of gravity representing all the parts and their kinetic energy. Their motion becomes increasingly uniform and acting relative to the center. It creates a field space, technically called a partial Cauchy hypersurface. The common term is singularity. This space has no entropy or energy it can emit. It is a surface tension representing the most elementary form of gravity. Yes, this is the singularity effect commonly occurring at the center of spiral galaxies where matter is known to be lost as it is pushed fatefully across the event horizon. Because it is a hypersurface, the temporal effect of crossing this boundary is annihilation, confining that value as energy to the available volume. Too bad the third law is only a product of our present subject and not the current subject. Speaking of things overlooked or not developed in Clausius' time, the rotational conversion as shown by Perkin's ice machine provides a fourth law. Fleming's rules then classify and organizes energy into a fifth law. It is hard to discuss any of these laws without incidentally addressing the other four. Quantum relativity conceptualizes advanced topics in established physics to provide educational and practical tools. Our biggest problems in physics are human, specifically too much information and no accurate standardization of the concepts. Basically, advanced physics needs an introductory class to put it all together. Remember to subscribe and stay tuned for other educational videos. Thank you.